Alright, so this is the continuation of Note 7.8 for my Honors Advanced Algebra 2 class. Today we went over properties of logarithms, being able to use those properties to expand expressions, also being able to use those properties to condense expressions, and then using a new thing called change of base formula. So we actually got finished with the expanding, we got partway through the condensing, and we didn't get to the change of base at all. So I'm going to go ahead and go over this entire thing again, except for parts where you guys needed partners. This is where we kind of explored and found out the properties. So just real quick review of the properties. There's three of them: product, quotient, and power. They are very similar to exponent properties in that if you have multiplication going on, then basically it turns into addition. If you have division going on, then you can subtract them. So you can separate them through subtraction. If you have a power, in class we went over why that's related to the product property. Basically a shortcut of this is that the power comes down front. So any power that's right here ends up being n, or whatever that power is, times however many, times the log base u. All right, so let's kind of go over this one again. Where's my markers? There they are. Okay, so with this, use the properties of logarithms to approximate the following to 3 decimal places. Now, in these type of problems, they're actually going to tell you what the logs are. So they tell us the log base 5 of 3 is approximately 0.683. We're also going to know that the log base 5 of 7 is approximately 1.209. So they tell us these two things. So what you got to do is you got to create new problems out of these so that you can pull a log base 5 out, since we know what that is, and a log base 5, 7 out. Sorry about that. Log base 5 of 7 is approximately 1.209, so we got to try to find log base 5s and 7s. So 21, what we figured out was, it's not that, whatever that is, that's an equal sign. Okay, you can turn this into log base 5. So the way to turn a 21 into a 7 and a 3 is that you know 21 is a 7 times a 3. Now I'm going to put it in parentheses, that way you know log base 5 of this whole thing, because it was log base 5 of 21. Now, according to the properties of of logarithms, when you have a multiplication going on, you can actually split it into 2 separate logs. So if that keyboard will leave me alone. Stop. No. Silly keyboard. Go away. You go up there. Okay, so this will turn into log base 5 of 7. That multiplication means that you're going to turn into addition. Log base 5 of 3. Now, the reason why we did that is because I know what log base 5 of 7 is. That is 1.209. So it's going to turn into 1.209 plus log base 5 of 3. We know what that is also. That is 0.683. Sorry if this is kind of messy, but I'm trying to use my writing pad again. Okay, so 1.209 plus 0.683, that is 1 point, let's see here, 8, and 9 plus 3 is a 12, carry the 1, 8, 9, 1.892. Okay, double check that, it's a 12, carry the 1, it's a 9, 6 plus 2 is 8, and there you go. Technically, right here should be approximation symbols, since up here it said it was approximately those. So at this point where you start plugging in those numbers, it's approximately this. You can put equals here because this step is equal to exactly what this step was, but you approximated right there. Okay, so moving on. Sorry if I'm going kind of fast, but I need this up by 5:30 if I want this to count for your homework. So let's go. Log base 5 of 3 divided by 7. So when you have a division, you turn it into subtraction. So it's going to be log base 5 of 3. So you subtract the bottom from the top, minus log base 5 of 7. So once again, we know what 3 is, we know what 7 is. The log base 5 of 3 is 0.683. minus log base 5 of 7 is 1.209. Okay. Whoa. My handy dandy calculator. So you're going to take Well, actually, I'll bring it up right here. Da, da, da. There you go. Okay, so we're taking 0.683 and subtracting 1.209 from it. It's not an O. Look at this. I might actually not put this up in time. 683 minus 1.2009. And that is negative 0.526. 0. Negative 0.526. Double check and make sure that was what it said. And yes, it was. Okay, so that's your answer right there. And this actually, once again, this should have been an approximation. Sorry about that. Okay, now 49. This is where I showed you guys two separate ways of doing it in class, but I'm just going to do it one way in here on the video. So log base 5. Now the 49, the only way you can turn a 49 into a 7 or a 3 is if 49 is 7 squared, basically. Now using the power product, the power property of logarithms, this exponent and the exponents are allowed to come down front. So that's going to be 2 log base 5 of 7. But we know what log base 5 of 7 is. That's 1.209. So that's going to be 2 times approximately 2 times 1.209. So we're going to multiply this out, and that is going to be 9 times 2 is an 18. Carry the 1. 2 times 0 is 0. And the 1, that's a 4.2.418. Okay, and that's it. All right, so moving on to the next part. If you have questions on this, make sure you guys write it down or something so you can ask me tomorrow. Okay, so the next part, log base 2 of this, what we're going to do is we're going to do what's called expand. So these are going to turn into longer things. Now, first things first, you should identify what operations are going on. So we got 7 times x, so we know that there's going to be a product property. We also have a division, so there's going to be a quotient property. We also have a power, so there will be a power property also. First thing you want to take care of, though, is probably this division sign, since it's this entire top part divided by this bottom part. So division signs turn it into subtraction. So this would be log base 2. 7 times x to the third. This division sign, I'm going to subtract the bottom part, so that's log. I'm not sure why all these extra lines are happening. Log base 2 of y. All right, so this was the top part, this was the bottom part. Now the bottom part, what you want to check for is either multiplying, dividing, or exponents. There's nothing like that around this y, so this part is actually expanded, this section right here. Then over here we have a multiplication and we have a exponent still. Don't bring down the exponent to over here first because that's just on the x, so we got to separate these first. So this will end up being log base 2 of 7. Since it's multiplication, you're going to turn it to adding. Log base 2 of x to the third. Okay, minus your log base 2 of y. And there's all kinds of extra lines going on for some reason. It looks like dog. Okay, so this one will be log base 2 of 7. This 3, using the exponent property, will come down to the front. So that's plus 3 log base 2 of x minus log base 2 of y. I'm not lifting it up high enough or something. Okay, so this is just a 7. There's nothing to break apart. That's just an x. There's nothing to break apart. No more exponents, no more multiplying. So since there's nothing like that left over, we only got 3 properties we got to check for. That is finished. We have expanded it. Okay, so let's go to expand this other side. What I was telling you guys in class today was that when you have a square root, you should think of that as a power. Since we have a power property, that's going to be 2 to the 1/2 times x to the 4th. Now looking at this, both of these, that's a 4. Both of these have exponents on them, but they're being multiplied. So you want to take care of the multiplication before you take care of the exponents. The exponents should be the last things you guys bring down. So we're going to separate these into log base 5 of 2 to the 1/2 power plus, because multiplication is turned into addition, log base 5 of x to the fourth. So all we did so far was separated them. That's a 4. All right. So now what we're going to do, the 2 doesn't break down anymore. We can bring down the 1/2 power to the front. So 1/2, 1/2 log base 5 of 2 plus, we're going to bring the 4 down to the front. So 4 log base 5 of x. Well, there you go. If I write slower, then it works out. Okay, so this technically is correct. I would mark you guys right if you left it like this. But on a few textbooks I've seen, log base 5 of 2, they actually, because when you multiply by 1/2, it's the same thing as dividing the whole thing by 2. So I've actually seen it a lot like this also. So 4 log base 5 of x. So yeah, the worksheet that I made for you guys actually have it starting like this on the next part, so I would like to see it like that. Okay, so that being said, let's go to condensing. So we did this one in class. I forgot to erase it, so I'll just explain the work here. Log base 6 came down. So when we were expanding, exponents were the last thing we took care of. So condensing is going in the reverse order. So the exponents is actually the first thing we want to take care of. So when you see a multiplication in the front, that actually came from the exponent. So it came down, but now we're working in reverse. So this 2 ends up back up here. That's where this 2 came from. Okay? All the rest of them don't have numbers in front, so you just leave them the same. So now we have this. The next step, all we did was 2 squared is a 4. That's all we did from this step to this step. Everything else is the same. Now we're going to focus, now we took care of the exponents, we got to look for the other 2 properties. The other 2 properties were the product property and the quotient property. So the product property is addition turned in from products, from the products turned into addition. Now we have addition and we got to turn back into products. So since there's addition here, that's going to be 6 times 4. So the plus signs turn into multiplication, so 6 times 4. Subtraction signs are division, so we're going to take that whole thing and divide it by 3. Okay? And then 6 times 4 is 24, divided by 3 is 8, so this whole thing turns into log 8. Okay, so this is the part that we didn't get to in class. So once again, we have a 2 in the front. We want to bring that up top. So this is going to turn into log base 3 of 7, and this 2 is going to end up coming up to the top of the 7. So 7 squared minus 5. Whoops. Sorry about that. That is a number in front also. So since this 5 is in front too, we know that this 5 belongs as an exponent since we are condensing. We're trying to make everything smaller. Put it all together. Just a little reminder that the bases have to match too. Okay, log base 3 x to the 5th power. So we brought all those up top. Okay, exponents are done. Now we're going to look for multiplication or subtraction, or sorry, either the product property or the quotient property. There's a subtraction, so there is a quotient property. So 7, so it's going to be log base 3. 7 squared is a 49, so I'm going to go ahead and put a 49 on the top. And then on the bottom is x to the 5th, so that's just going to stay x to the 5th. A lot of times people put parentheses around it just to make sure that you know you're taking the log of this entire thing. I'm okay if you leave it off, but it looks nice if you put it on. All right, so that's condensing. All right, next part, change of base formula. All right, so this is the part that we missed in class completely. What the change of base formula is, you can change any logarithm base to a new base using this formula. So if you take log base c, c can be any number, of u, that's the same thing as log base b. Notice that the c base turned into a b base. So that's another number that's not c. So say c was a 5, b could be a 6, and then another 6 right here. So log base b of your new base of u, so you put u here, and then log base b of c. So this old base becomes your new part right here. So what I was going to do in class was show you how that works with log base 5 of 25. We already know what log base 5 of 25 is. If we use the spiral, 5 to the 2nd power is 25. So we know that. We know that the answer is 2. But using the change of base formula, Now, the base that you would want to change it into is bases that are very simple in your calculator. So a base right here that's simple in your calculator would be 10, because log base 10 is just log in your calculator. Or you can change it to the natural base of e, because log base e is the ln button on your calculator. So if we use this formula, you can plug this in as log of 25, because that's log base 10, right, over log of 5. So we know the answer should be 2, so technically we can change this base 5 into base 10s. So to just double check to make sure that this is true, I closed the calculator. No, I didn't. Okay. So we can do log of 25. There's my log button. So 25, whoa, 25 log divided by 5 log. So log 25 divided by log of 5 equals 2. There you go. So that shows that it works. So this is a 2. Okay, so that's how the change of base formula works. Now it also works with ln, because remember ln is log base e. So we should get ln of 25 over ln of 5 is actually a 2 also. And let's make sure about that, just to prove it to you. So we got 25. Here's my ln. So the ln of 25 divided by 5 ln. So ln 25 divided by ln 5 is equal to 2 also. So that's how the change of base formula works. All right. So let's go and try this out here. So either one's fine. You can use the natural log or the common log. Whichever button, I guess, is easier for you to get to. So log base 3 of 7. So what this is going to turn into is, I guess I'll do this one with ln. So ln of, and then ln on bottom. So I changed my base from a base 3 to a base e, the natural logarithm. Now the only part that people mess up here is where they put the 3 and the 7. Now, usually it's easy to remember that the big number, this already looks like it's on top. So ln of 7 goes on top, ln of 3 goes on the bottom. So to plug it in your calculator, where did the calculator go? Did I close it? No. Okay, calculator. So 7 ln divided by 3 ln is equal to 1.771. So 1.771, that's approximate, and there you go. That's how you use that. Okay, same thing here. So it should be 3 to this power will actually give you a 7. So let's check that too. All right, so 3 to the 1.771 should equal just about 7, 6.998. So we know we did it right. Okay, same thing here. You can use log here, log base 10, common logarithm, or ln. I'll just keep using ln. ln of 8 over ln of 4. Remember the 8 already looks like it's on top. And that's going to be, well, it's going to be approximation here. It's not going to be exact. And I closed it again. Why did I do that? Okay, so 8 ln divided by 4 ln equals, oh, 1.5. So that's exactly 1.5, so we don't need that there. 1.5, 1.5. And there you go. To double check your answer, do 4 to the 1.5 should be an 8. And that sounds right, so that's fine with me. Okay, so, and that's it. So that is all. Tomorrow will be a work day, and make sure you guys write down any questions you have for me. Okay, and it is 5:02, so let's see if I can get this uploaded. Bye-bye.